Hi everyone, my name is Çiğdem Aybar and today I am going to talk to you about D3, data-driven documents. Before just jumping into D3, I want to talk about a little bit about data and data visualizations, why they are important. We all know data is important to make decisions, either for government decisions, for private decisions, company decisions, or even for personal decisions. But data is like crude. Without refining it, we cannot really come up with conclusions. And when we have the raw data, it just looks like this. And from here, we know that we cannot actually see the relationships, how each column is working together. And where we are using data visualizations are for this situation. We want to see the relationships and we want to draw conclusions after seeing these relationships. This snippet is from the D3 website homepage, and if you click on each hexagon on the web page, actually it gives you the whole source code of the data visualization, and we can see that we have many examples and options to see the data in different ways. Let's talk about D3. D3 is a JavaScript library. It was released in 2011 by Mike Bostock and his colleagues. Mike Bostock was working up until 2015 in New York Times, and all the visualizations in the on the website of New York Times, actually his team's work. Also, D3 is a front-end client-side technology. So what do we need to know actually in order to use and utilize the D3 functions? First, we need to know JavaScript. It's a JavaScript library, HTML, CSS, and SVG. For the ones who are not familiar with SVG, SVG is a scalable vector graphics. It's a family of specifications for creating two-dimensional vector graphics. Vector graphics are not created out of pixels. That's why if you zoom in or zoom out, you will not lose the image quality. And let's look at a couple of the D3 examples to make you more interested about its visualization capabilities. Here we see bubble chart. Bubble charts are less perceptually accurate than the bar charts, but we can put a lot of information, data into a small space. Here we can see that different categories are represented with different color schema, and each circle represents how much data it has. So we can compare different categories with each other as well. This one should be familiar from the GitHub's contribution chart, and this is a heat map. With heat maps, we use different shades of the same color to show that when we have the darker colors, it represents that more contributions has happened. I really like this one. It's hierarchical edge bundling. Actually, it is an interactive one. If you go to the website and if you move over one of the nodes, it will show the dependent ones and dependencies, and also the dependent ones. The dependencies are in red, and dependent nodes are represented with the green one. Parallel cells, I actually really found this one interesting because here you can see that different categories and also the relationship between categories really well. If we look at this parallel cells example, we can easily say that the actually not survived portion of the Titanic group was mostly from the third class and crew, adult, and male. Choropleths they are widely used as well. In this one, this choropleth shows the unemployment rates as of August 2016, and the unemployment rate for the regions with darker colors are higher compared to the regions with lighter colors. Okay, these examples are nice, but how actually D3 is doing this? D3 is loading the external data. You can load CSV files, step-separated value files into your HTML and your file. And It appends, removes, and style DOM elements, uses CSS style selectors to select nodes and manipulate them similar to jQuery. Then you can bind the data to the selected nodes and transform the data to fit your visual requirements. Now, I don't want to scare you with this code snippet. We are going to talk about this one. And actually, after seeing all the nice visualizations, with this code snippet, what we are going to build is a bar chart. Bar chart is not as visually appealing as the other ones, but I thought that it is a good starting point in order to understand how D3 works and maybe start from the basics. And we will come up with this bar chart at the end. I'm not going to live code. I will just comment out some parts just to show that while I'm commenting out how it is affecting the final result. Right now we have an SVG container, and with the script file here, we are importing the D3 to our document. And SVG container, here we can see it's in pixels, how big it is. The width 960 and the height 500. But then what we are doing here is creating the margins and calculating the width and height. So we are going to use width and height information in order not to have our bar borders at the end and at the top or at the bottom of the SVG container, so we can really read the information on it. Scale bands, they are used to create bar charts, and they usually take an input, a number, date, or category, and return a value, such as a coordinate, a color, a length, or radius. They are typically used to transform or map data values into visual variables, such as position, length, or color. So when creating bar charts, scale bands help to determine the geometry of the bars. What we are saying here is actually it will start from 0. Our range will start from 0 till the width. And with the scale band function, we know that if we have n variables that we are going to represent on the x-axis, we are putting a padding around the bars so they won't be all squished next to each other. And scale band function will calculate for us easily for n variables how many bars we will have, and we will have n, and how they should be located on the x-axis. The G element is the group element in SVG. So G elements are really useful because instead of using nested SVG elements where you need to actually transform each SVG element individually, you can just group under the G element and transform all the data together. With this G element, you can see that we are actually, with this calculation here, it is translated to 40/20. So our origin for the websites, it starts here. And the coordinates are 0 to 0. In order to move here, we are making a little bit calculation with the margin left and margin top. And it gives us 40 to the right and 20 to the below. This is where D3 is bringing the data into the file function is happening. This data TSP file, it has the letter frequencies of the English letters in a dictionary. We are bringing the data into the file, and then since it's a text file, here we are basically just changing the frequency into numbers. The domain function here actually gives us an array of values. What it does is it says that on the x-axis we are going to have all the letters in the alphabet, and for the y-axis it will go to the highest frequency value and starts from 0. And from here we can see the highest one is about 12%. Let's uncomment this out and see what we are getting. We just appended a new G-group elements with the x-axis class and transformed its height with the letter values of the alphabet. And you will see that we didn't have this before. What is good about D3 is also when here you don't really see it, but we will come when we are talking about the bar class. Then if you use a select class, even if it cannot find it, it will create it for you. So it will know that, okay, I am going to do something about this class variable, so I need to use this. I need to create these elements. And for the y-axis, what we are thinking we are going to get is the frequency values on the y-axis. And this is how this G group is doing. And it goes up to 12 because here how we are actually set it up. Since we are tight a little bit with the time, I am just going to walk over to you with the last one. And with the last one, we are saying that select all bar classes. And as I said, like even if we did not have the bar class before anywhere on the page, it knew that it is going to create it. It will bind the data. And all of them will be a rectangular. And the calculation for the height is happening here in this function, according to the frequency. When you hover on them, you can see that its color is changing. D3 is really powerful to use, but also it has its own limitations when it comes to working with the virtual DOM elements. That's why I was thinking of including the React implementation of this, but first we need to really understand how D3 works in order to really combine it with the React version. I use this D3 website in my presentation and in my research a lot. The contributions, examples are there, is amazing. And I strongly suggest, and all the examples, you can find the codes there. And for the further reading, I suggest the React D3 website. There are multiple libraries you can actually use. And the D3.js is really good when it comes to integrating D3 to the React. Thank you. I hope you enjoyed the presentation.